Hello everyone, Dr. Polaris here. While it was once thought that Mesozoic mammals were limited to being tiny, shrew-like insectivores, discoveries in recent decades have shown that this was generally not the case. While yes, the mammals that thrived during the so-called Age of Dinosaurs were relatively small by modern standards and did not produce any megafaunal species, they were still pretty diverse. Iconic forms such as the multituberculates filled niches similar to those of modern rodents, ranging from tiny omnivores to bulky gopher-like herbivores. The monotremes produced burrowing and semi-aquatic platypus-like species with electroreceptive bills. And some groups, like the subject of today's episode, the Eutriconodonts, were largely carnivorous. This diverse radiation of Mesozoic mammals first appeared during the early Jurassic circa 190 million years ago, and were common and widespread animals well into the Cretaceous. Native to most continents, Eutriconodonts were faunivorous and ranged from tiny shrew-like insectivores to some of the largest of all Mesozoic mammals, being carnivores comparable in size to modern badgers. Traditionally, it was thought that these animals were crown group mammals in a more derived position than the monotremes. However, a few recent studies have indicated that Eutriconodonts may not even be crown mammals at all, instead possibly being stem mammalia forms similar to the docodonts. It's also been suggested that they might not be a natural lineage, representing several groups that have been artificially lumped together. Regardless of this, Eutriconodonts generally share a number of anatomical features, such as their distinctive three-cusped molar teeth, as well as skeletal traits common in non-therian mammals, such as epipubic bones, tarsal spurs, and semi-sprawling limbs. The structure of their inner ear was generally similar to that seen in modern mammals, although their ear ossicles were still connected to the jaw via the Meckel's cartilage. Thanks to the well-preserved genus Spinolestes, we know that these animals possess hairy coats and external ears very much like those of living mammals. The most basal forms, although interestingly not the oldest, were the Amphilestids. Spanning from the Middle Jurassic to the Cenomanian stage of the Cretaceous circa 93 million years ago, there is little information available concerning them online, although they seem to have been small insectivores. The genus Phascolotherium from the Middle Jurassic of the UK was tiny, with the species P. simpsoni probably weighing less than 9 grams, being comparable to a small shrew in size. The more derived Gobiconodontids, meanwhile, tended to be on the opposite end of the size spectrum, originating during the beginning of the Middle Jurassic roughly 184 million years ago with the poorly known Mexican genus Huasteconodon. These were among the first mammals to specialise in hunting other vertebrates. These animals possessed occluding molar teeth that would have given them shearing bites that were able to tear through flesh and in some cases to crush bone. Gobiconodontids also tended to have prominent fang-like incisor teeth that were larger than their canines, which is very different from modern carnivorous mammals. This was especially true of the very successful genus Gobiconodon, which was native to Eurasia, North America and possibly Africa during the early Cretaceous. As many as 10 species have been assigned to Gobiconodon, although some of these may need their classification to be reassessed. All would have somewhat resembled hybrids of opossums and mustelids, being long-bodied plantigrade carnivores with powerful jaws and robustly built limbs. Their incisors were large and functioned like the canine teeth of living carnivorans. The different species varied in size, with the largest being G. ostromi from the Cloverleaf Formation of Montana, which would have been comparable to a modern Virginia opossum in mass, weighing up to 6 kilograms or 13.2 pounds. Interestingly, this animal would have been one of the few Mesozoic mammals to actually prey on dinosaurs, with the tiny ceratopsian Aquilops potentially being on the menu for Gobiconodon. However, it would have had to look out for the leopard-sized Dromaeosaur Deinonychus, as well as young Acrocanthosaurus. The most famous member of this family was the genus Repenomamus, which was native to the Liaoning province of China between 125 and 123 million years ago. This superficially badger-like mammal possessed a large, robustly built skull equipped with shearing molars, an elongated body and relatively short, powerful limbs. 2 species are known, with these being the smaller R. robustus, which was similar in size to Gobiconodon at up to 13 pounds, while R. giganteus was roughly 50% more massive, being one of the largest of all Mesozoic mammals at up to 14 kilograms or 31 pounds. This is comparable to a modern European badger. From the remarkably well-preserved remains of this genus found in the Yixian Formation, we know that these animals actively preyed on small dinosaurs, with a specimen of R. robustus containing the fragments of a juvenile Psittacosaurus skeleton in the stomach cavity. Another even more amazing specimen represents the near-complete remains of an R. robustus individual caught in the act of ambushing a potentially sleeping adult Psittacosaurus. Similar to the famous fighting dinosaurs fossil from Mongolia, this find demonstrates that Repenomammus actively hunted Psittacosaurus and potentially other smaller non-avian dinosaurs found in the Yixian Formation. Other Gobiconodontids were similarly well preserved but were far smaller, as was the case with the unusual Spinalestes from the early Cretaceous of Spain circa 125 million years ago. Known from the Los Hoyos Formation and represented by an incredibly well preserved holotype specimen complete with fossilised soft tissues that include hair, skin, internal organs and external ear flaps, Spinalestes was about the size of a small black rat and weighed between 50 and 70 grams. Its furry coat was similar to that of modern mammals, with guard hairs that were spiny and likely served a defensive purpose. It also appears that this animal suffered from a fungal skin infection, which is the only confirmed example of such an affliction in a Mesozoic mammal. Interestingly, the genus also possessed several anatomical traits convergent with those of Xenarthrans, including robust Xenarthrous vertebrae that would have stiffened the spine and which probably represent an adaptation for pushing under rocks and heavy logs in search of invertebrate prey. Outside of Gobiconodontidae, there were plenty of other Eutriconodonts that thrived during the early Cretaceous, which was the time in which these mammals reached the apex of their diversity. These include the arboreal insectivorous Jeholodens, which was a small and probably nocturnal animal endemic to China and somewhat resembled modern opossums. It notably possessed a long tail and grasping front feet, which were well adapted for climbing. Meanwhile, the slightly younger Liaoconodon was a semi-aquatic otter-like genus, also native to China between 125 and 112 million years ago. Measuring about 35 centimeters or 1 foot 2 inches long, this animal's body was streamlined for effective swimming, being powered by a long flattened tail. Like other Eutriconodonts, Liaoconodon was a predator, feeding on fish and aquatic invertebrates in its marshy wetland habitat. Its inner ear structure was transitional between that of earlier mammalia forms and modern mammals, with an ossified Meckel's cartilage which supported the eardrum. However, arguably the most successful of all Eutriconodonts were the Triconodontids, a family that first appeared during the first half of the Jurassic and potentially survived right up until the KPG extinction event 66 million years ago. Older Jurassic forms include animals such as Eutriconodon from the UK, as well as Priacodon from the famous Morrison Formation, both of which were small insectivores. The type genus Triconodon was significantly larger, being about the size of a domestic cat. Also native to the UK and possibly France during the late Jurassic, examinations of its brain case have shown that this animal had a strong sense of smell and would have been a carnivore that fed on small vertebrates. Another possible member of this family, Indo-Triconodon, persisted on the island continent of India right up until the end of the Maastrichtian circa 66 million years ago, although its exact classification within Eutriconodonta is unclear. This was yet another large form, being only 20% smaller than Repenomammus giganteus. By the mid-Cretaceous, Eutriconodonts had largely vanished from Eurasia, although some forms persisted in North America until surprisingly late into the period. These were all members of the subfamily Alticonodontinae. Two of these, Astroconodon and Jugulator, were both native to the Cedar Mountain Formation of Utah between 112 and 94 million years ago, dwelling alongside famous dinosaurs such as Deinonychus and Tenontosaurus. Astroconodon was a small insectivore, while Jugulator was a significantly larger carnivore weighing up to 750 grams, which is comparable to the modern American mink. The youngest of all North American Eutriconodonts was the genus Alticonodon from the Santonian to early Campanian Milk River Formation between 84 and 83 million years ago. It was a highly specialised hypercarnivorous animal, perhaps as a result of having to compete with predatory metatherians. Meanwhile, the final lineage of Eutriconodonts that we still have to cover are definitely the weirdest and most specialised. These were the members of the clade Volaticotherini, a lineage of insectivorous and carnivorous gliding mammals. 4 genera are known, with their main unifying characteristic being their highly distinctive molar teeth, which possess tall backward curving cusps. When combined with their large canines and sharp incisors, this suggests that these animals were carnivores. Native to East Asia, Africa, South America, and potentially North America, these widespread species first appeared during the Toarcian stage of the Jurassic, circa 179 million years ago, and survived until the very early Cretaceous. The type genus, and by far the most well understood member, was Volaticotherium itself. Native to the Middle Jurassic Daohugo beds of northern China, circa 164 million years ago, this genus was a rat-sized arboreal insectivore. It's represented by an incredibly well-preserved holotype specimen that contains the fossilised impressions of hair and, importantly, an extensive patagium of skin that extended between the body, limbs, the base of the tail and the digits, combined with an elongated flattened tail that would have acted as an aerofoil. This shows that Volaticotherium was a gliding mammal, similar to modern flying squirrels, albeit with a faunivorous diet. Indeed, most living gliding mammals tend to be herbivores or at least omnivores, which makes Volaticotherium quite unusual, although the currently undescribed hypothetical ancestors of bats must have also gone through an insectivorous gliding stage before developing powered flight. Other members of the group are far more fragmentary, though at least one other genus, the older Argentoconodon from mid-Jurassic Argentina, possessed limb proportions that were very similar to Volaticotherium, indicating that it too was a specialised glider. However, the structure of its teeth indicates that Argentoconodon was a carnivore that probably fed on other small mammals, rhynchocephalians, and perhaps even hatchling pterosaurs. Another, even more poorly known genus was Ichthyoconodon from the very early Cretaceous of Morocco, represented by just 2 molar teeth with distinctive sharp backward curving cusps. This animal has sometimes been argued to have been a semi-aquatic piscivore due to the shape of its teeth, as well as the fact that its remains were recovered from marine deposits. The teeth also showed little degradation, indicating that the animal either died in situ or was only carried a short distance underwater. However, given the very fragmentary nature of these remains, Ichthyoconodon may have been a glider like its better known relatives, with its body simply being rapidly swept out to sea after it died. Another potential Volatocothere may have been the genus Triconolestes from the late Jurassic Morrison Formation of North America, although the exact classification of this animal is uncertain. Although the early Cretaceous represents the high watermark of Eutriconodont diversity, the group had begun to decline going into the second half of the period. Some holdouts, such as Alticonodon, persisted in North America until roughly 83 million years ago, after which the group vanishes from the northern continents. This decline was probably due to the faunal turnovers of the Middle Cretaceous that disproportionately impacted insectivorous and carnivorous mammals, rather than the Eutriconodonts simply being outcompeted. After their demise, the Metatherian deltatheroids became the dominant carnivorous mammals across the northern hemisphere. However, Eutriconodonts clearly survived beyond this point in at least parts of Gondwana, given that the Indian genus Indotriconodon persisted right up until the KPG extinction event 66 million years ago. This means that the diverse Eutriconodonts were an incredibly successful and long-lived group, with an amazing 130 million year history. Their wide range of body plans and adaptations also helped to demonstrate that Mesozoic mammals were far from being just tiny, supposedly boring shrew-like things that lived purely in the shadows of dinosaurs. Thanks for watching, everyone. In the next episode we're going big, examining the eusauropods, focusing in particular on the diplodocoids. See you again soon. Cheerio.